class. All right. Today we'll have another online class to covering chapter 8 by Tahir and myself, and then there is a discussion session by Tahir. All right, and also I just sent you homework 3 through the KakaoTalk. So you can check the homework 3. And then next week there will be no class hours, and we start from 19th of Monday about project presentations. Okay, any question on schedule? No, then we can start from Tahir. Tahir, you should use this monitor or PC notebook from Imgyu. Can you share your screen so that we can see the presentation? All right, go ahead.
We are on chapter 8. I'm Tahir, was to today's lecture. This is our book.
Tahir, I cannot hear you well. Can you use something? Microphone? 목걸이 마이크폰이 없는 모양이군요.
Hello.
Hi.
Can you...
Yeah, it's better. 목걸이 마이크폰을 쓰실 거 그랬어. 네, let's go ahead.
We are on chapter 8, that is design by feature techniques. So, what chapter 8 covers is architecture, framework, procedural techniques, declarative techniques, feature refinement, feature relations, product family modeling, and cutting and pasting of features. So, I will be covering only architectural framework. So, first, there is a little bit of background. Why design by features? Actually, it starts from the very early, like when we have the available geometry in any neutral format like IGS or STEP, then we apply feature recognition techniques for manufacturing purposes. So, what designers want to do is to take advantage of feature techniques in the design process. So, resolving the issues on the very design level instead of going to the manufacturing level. And in this chapter, we will discuss with perspective of the developer, like we are developing the feature-based modeling app. So, there are two main approaches, procedural approach and declarative approach. I will explain them in later chapter. So, here are the contents which I will explain. Architecture frameworks background, representation of feature definition, support for user-defined features, and types of linkages with a geometric modeling system. First, there is a background. Representation of the feature definition, what a definition should contain. It should contain some specific types of values and how it should be defined for a specific feature. Next is level of support for user-defined features. So, not all the features in a CAD modeling system are available, are very effective for the user. So mostly users define their own features. So that is the user-defined feature. The third one is the types of linkage of the geometric modeling system. And the geometric modeling system is basically the geometric kernel, but in the book, the word used is the system. So I kept it that way, geometric modeling system. And the fourth one is the application context. Application context is with reference to the application in the design, like aerospace industry, automotive industry, or shipbuilding, plant CAD. So in these type of industries, feature definitions change, and the mechanical, which is very general, and the support for feature validation, which is very necessary because whenever you define a feature, you have to validate it. I will explain the representation of the feature definition. So what are the definition of the feature contain? Generic feature definitions, very general, and these definitions should contain the information types, which can be divided into three types, like attributes, like sketch or solid geometry, and other is the information type. It contains a boolean like unite or subtract or do nothing, or it contains some double like 14.009 something, and the range, over which range it does not work. I will explain this with the round feature. So here you can see round feature is defined in 1. Then I have increased the diameter in 2, and then in 3 the diameter is so much that it cuts off the other part of the model. Here you can see that it cuts off the other part of the model. So, but when I increase the diameter further, the system anticipates that what I'm trying to do, and it itself just only changes the dimension of the other side, not the main. So here you can see that. So here we have a circle which we have selected, and the other information is the dimension, and the third one is if it is cutting off or not, but it is inside the system, not in my control. It was designed on Q 5.0, which is a recent one. So, and now I will explain the procedural versus declarative feature definition. So first, can you give an example of procedural language and non-procedural language? Anyone? I have a gift for you.
Then I should answer. One of the example as professor gave us in the start of the procedure was the chessboard, like.
No, it is the language, computer language. Procedural computer language and non-procedural computer language. Actually, professor explained them. That is why I am asking.
So the Mutar saying there is a similar slide from my side, right?
No, Professor, you have explained the procedural computer programming language and non-procedural computer programming language. I'm just asking them, do they remember or not?
Say again, asking what?
I am asking them if they remember the name of procedural computer programming language
I see.
Non-procedural computer programming.
So it's non-procedural, maybe object-oriented
Yeah,
programming language.
yeah, right.
I can't think of an example of a procedural language.
Okay. So you can say after.
There is a category of symbolic computation. You can find out. So that kind of category of computation or language can be categorized as non-procedural languages. All right, go ahead.
By the procedural language, we define the C. C is a procedural language. So in the case of procedural feature definition, all these functions are based on are in a procedural manner, and so are its relationships. It's more like a history-based system, whereas in the case of declarative feature definition, it is not procedural. Like we said, it is object-oriented, like C++, where we can define the methods. So it is very declarative, and in what it is important here is that the relationships are decoupled from the computation. You just input the information, and whereas in procedural language they cannot be decoupled, and in the case of declarative we have rules and constraints. I will explain them as declarations. So in declarative feature-based definition, we have three main categories: constraint specification. So for constraint specification, we will require a constraint satisfaction algorithm. We have rules, and for the rules, we will require inference engine. And the third one is the predicate logic. It is more like booleans, true or false. So for that, we will require unification algorithm. What is the advantage of declarative feature-based definition? That it is readily transferable from one feature-based system to another. Like exchange is very easy. You can convert one native system's CAD file to another. So it is the advantage of the declarative system. So the next is the implementation strategy of hard-coded feature definitions. In the case of hard-coded feature definitions, it is an the feature defined in an ordinary programming language, where this language is not usable by the end user. He cannot manipulate it, but it is compiled and linked, and it then performs. Whereas in interpretable feature definition, an interpretable language like Lisp is used. The language can be general purpose or special purpose, but here you can define your own features, so it's more readily available, and it is interpretable by the end user. Like he can program the features. And the the last one is the prototype-based feature definitions. These are really strict. Like these are instances, and these can be used as templates. Like if you have used any 3D modeling, artistic modeling engine like Maya or Blender, they have various templates which you can manipulate to make a shape. Next is support for user-defined feature. So first we will divide the model into two categories, like features available to the user and the collection of features actually preserved in the resulting model. So if you make up a model, then what features you use for making it and what the system remembers out of it are different. For example, you have made a connecting rod and you have defined it as a feature. So whenever you want to make a connecting rod, you will go and make it from your user-defined features, but for the system, it is a collection of extrudes, holes, and etc. So, but there is a limit. As you can see the graph here, extendability of the user interface features is at one extreme, and extendability of internal model features is another extreme. So I will explain this later after this slide. So alternate approach to supporting user-defined features. Here I will explain in more detail. When a simple design by feature system is used, it is fixed and the collection of features cannot be extended. It is very restrictive and it is not good for an innovative design. Whereas user-defined features such as macro with hard-coded values which you can change. And extendable features are based on interpretable language, and for a complete support of user-defined features, user have to define the feature class. Like for the connecting rod, you have to define all the features that this would contain. So that feature class is defined by the user. So these are two extents like this. If you want to contain full user-defined features, then you are on the x-axis at this extreme. But if you want to just make out of the available features, then you are on the other extreme. And next is types of linkages with the geometric modeling system. As I have explained earlier, the geometric modeling system is the geometric kernel. So the feature-based system and the geometric modeling system have to be linked for the modeling. So these are some properties. Closeness of the linkage, like if the linkage is static or dynamic, or like you have to, after completing your features, then you send your model to the geometric modeling system, or it is in the runtime. And the second one is the information flow. Either it is a one-way flow, like from feature-based system to the geometric modeling system and or from geometric modeling system to the feature based design system and or it is like one information comes from feature-based design and goes to geometric modeling system, and then it goes back to the feature-based system. And the third one is incremental or non-incremental operation. It is based on the feature propagation. For example, in incremental approach, if you have made some changes in your design, then you have to regenerate whole model in your geometric modeling system. Whereas in the case of non-incremental operation, you do not have to make the whole model, so it is time. It saves time as compared to incremental approach. And the last one is locus of control. Like what is the main program, or if you are using the geometric modeling system as your main program or the feature-based system. So here I will explain with pictures. So in this, you can see that design by feature system is our main program, and geometric modeling system is our secondary program. So the information flow is one way from the design by feature system to the geometric modeling system. And second one is the reverse order from the geometric modeling system to the design by feature system. And information flow is one way, and the main program is your geometric modeling system. And now, this is more like a dynamic linkage with either design by feature system is your main program or geometric modeling system is your main program. And information flow is two-way. And geometric modeling interface is more like a filter that controls the information flow and some conversions. So, any questions?
What about the modern CAD system? Which type of linkage they follow?
You asked about the modern CAD system. So, in the case of modern CAD system, we have both the declarative and procedural approach, but these are decoupled, and the linkage is also the last one, as I showed you. That you are controlling the geometry, and it is more like non-incremental, which I have explained. Non-incremental operation, like you do not have to regenerate the model as a. This page? Yeah.
When information flow is one way, is the linkage static?
Actually, I do not know about this because I could not find any relative study, but it should be static.
Because you said the third diagram is, I think it is two-way.
Yeah.
And you said it is dimensional.
Actually, in this case, feature validation is easy. But in case of one-way, feature validation is not easy, as you can see. So, with that respect, I said.
You may think about TV broadcasting system. That is one way, right? Usually, you just watch what they provide. So that kind of thing, you can say one way information flow. So there is no interaction. But nowadays, many TV programs provide user participation through typing in or some other way, or voting. So that kind of thing, we can say two-way information flow. So can I see the right-hand side two-way diagram? And next one. Right. So if you think about your TOM project, you are using, say, FreeCAD, then the geometric modeling system is underlying open cascade, and design by feature system is your own developing TOM project system. So I guess it is a two-way system, should be. If you control your menu, then the display changes. Right? Some calculation is done by open cascade, and then result is displayed on the screen. So it can be a two-way system. All right.